Class, let me ask you a question. What if the universe you live in, the air you breathe, the stars you admire, even the laws of physics that make your body exist, are not as permanent as they seem? What if everything around you is temporary? The hook. We often imagine the end of the world through familiar lenses. Asteroids colliding with Earth, climate catastrophes, a nuclear chain reaction. But there is another doomsday scenario, one so vast, so silent, that it makes all others seem small. It's called vacuum decay, and it begins not with fire or explosions or chaos, but with a single event at the quantum level, the collapse of the false vacuum. The false vacuum hypothesis. To understand this, let's borrow a metaphor. Imagine a marble resting in a shallow valley. It looks stable. It sits there unmoving. But if there's a deeper valley nearby, and the marble is nudged ever so slightly, it will roll down into a new resting place. That's our universe. We think we're stable. Atoms hold together, stars burn, galaxies spin. But if physics is right, our universe might just be a marble in a false vacuum, a shallow valley, not the lowest possible one. If the marble rolls, if the false vacuum collapses into a true vacuum, the rules of physics themselves would be rewritten. The Higgs connection. This isn't wild speculation. In 2012, when CERN's Large Hadron Collider discovered the Higgs boson, physicists celebrated, but they also noticed something chilling. The measured mass of the Higgs suggested that the universe sits precariously close to the edge of stability, not fully stable, not doomed tomorrow, but metastable, like a ticking time bomb with no countdown clock, the unimaginable end. So what would vacuum decay look like? Picture this. Somewhere in the universe, a tiny bubble forms, a region where the vacuum collapses into the true lower energy state. That bubble expands outward at the speed of light, rewriting physics as it goes. Atoms fall apart. Chemistry stops. The very concept of time could unravel. And the most horrifying part? We'd never see it coming. No warning, no alarms, no escape. One moment, we exist. The next, silence. Closing the chapter. This is why vacuum decay is one of the most terrifying apocalypses ever proposed. Not because it's loud, but because it's absolute. In the words of Stephen Hawking, the vacuum is not completely stable. At any time, it could decay into a lower state, and that will be the end of time for us. And so, today we begin a journey into the physics of the end. Next, we'll dive into Chapter 2, the physics of doom, what vacuum decay really means. To truly understand vacuum decay, we need to talk about something invisible yet fundamental, the vacuum itself. Now, most people think of a vacuum as empty space, nothingness. But in physics, the vacuum isn't empty at all. It's a field of invisible energy, buzzing with activity, even when there's nothing there. The quantum vacuum. In quantum mechanics, nothing doesn't exist. Particles are constantly popping in and out of existence, fleeting ghosts called virtual particles. This restless, fluctuating sea is governed by fields. And one of the most important is the Higgs field. Think of the Higgs field as an invisible ocean that fills the entire universe. Every particle that has mass swims in this ocean, gaining weight and substance. Without the Higgs, there would be no atoms, no chemistry, no life. False vacuum versus true vacuum. Now, here's where it gets strange. Physicists believe the Higgs field may not be in the deepest possible valley. It could be sitting in what's called a false vacuum, a temporary resting state. Go back to our marble analogy from Chapter 1. Imagine a marble resting in a valley on a hill. It looks stable, but if there's a deeper valley nearby, the marble could one day tunnel through the hill and roll down to a lower state. That deeper valley is the true vacuum. If the Higgs field ever tunnels into that state, the energy of the universe itself would collapse into a new set of physical laws. What changes in a vacuum decay? If vacuum decay happens, the bubble of true vacuum would rewrite physics as it spreads. The speed of light could change. The forces of nature, gravity, electromagnetism, the strong and weak nuclear forces, could be altered. The building blocks of matter, protons, neutrons, electrons, might not survive at all. In other words, atoms would simply fall apart, and because the bubble would expand at the speed of light, nothing could outrun it. Why physicists take this seriously? This might sound like pure sci-fi, but serious scientists discuss it. In fact, Nobel Prize winning physicist Frank Wilczek once called vacuum decay the ultimate ecological catastrophe. Even Stephen Hawking warned about it in his lectures. The vacuum is not completely stable. At any time, it could decay to a lower state. And in 2013, calculations based on the Higgs boson's mass suggested that our universe may indeed be metastable, balanced on the edge between safety and collapse. The scariest part, now here's the cruel twist. If vacuum decay begins somewhere in the cosmos, the bubble front would race outward at light speed. There would be no warning, because nothing can travel faster than light to alert us. It would simply arrive, and in less than a blink, Earth would vanish into a different physics, or into nothing at all. So when physicists talk about vacuum decay, they're not describing fire or chaos. They're describing an instant erasure of reality. Next, in Chapter 3, we'll explore, could this actually happen? What could trigger vacuum decay? And has it already started somewhere in the universe? So far, we've understood the concept. Our universe may sit in a fragile, false vacuum. But the question that keeps physicists awake at night is, what could push it over the edge? 1. Quantum tunneling, nature's silent killer. At the smallest scales, the universe plays dice. Particles don't just move smoothly, they can tunnel through barriers popping up where they shouldn't be. Now imagine the entire Higgs field, the ocean of reality, quantum tunneling into a deeper valley of energy. It wouldn't require a nudge from us. It could simply happen. Statistically rare, yes, but over infinite time, even the rarest event becomes inevitable. This is the first and scariest trigger. Vacuum decay could begin spontaneously, anywhere, anytime. 2. High-energy cosmic rays. Every second, Earth is bombarded by cosmic rays, high-energy particles from exploding stars, and black holes. Most of them are harmless. They crash into our atmosphere and fade. But some reach energies so extreme they dwarf anything we can build on Earth. If one of these collisions struck the Higgs field in just the wrong way, in just the wrong place, it could be enough to nucleate a bubble of true vacuum. In other words, the universe has been rolling the dice on us for billions of years. 3. Particle accelerators. Are we playing with fire? Now here's where it gets controversial. In 2012, when CERN's Large Hadron Collider confirmed the Higgs boson, some critics worried. What if smashing particles together at such energies could trigger vacuum decay? Physicists reassured the world. Cosmic rays already reach far higher energies naturally, so the collider is safe. And yet, Nobel laureate Frank Wilczek once admitted, "We are conducting experiments that have never been done before, and we don't know for sure what will happen." It's unlikely, yes. But the truth is, every time we probe deeper into physics, we're nudging the universe in ways never tested. For, has it already started? Here's the chilling thought. If vacuum decay begins somewhere in the universe, we wouldn't know. The bubble front moves at light speed. If it started a billion light years away, it could be racing toward us right now. Invisible, undetectable, unstoppable. And when it arrives, everything we know disappears in less than a blink. So perhaps the end isn't waiting in the future. Perhaps it's already on its way, closing the chapter. But don't despair just yet. In the next part, we'll explore Chapter 4, the timeline of the end. When do physicists think vacuum decay could happen? From trillions of years to tonight, the answer may surprise you. Now that we know what vacuum decay is and how it might start, the natural question is, when? Is this an apocalypse for the distant future or a ticking clock we can't hear? 1. The vastness of cosmic time. First, let's zoom out. The universe today is about 13.8 billion years old. Stars live for billions of years. Galaxies drift across unimaginable distances. When physicists talk about vacuum decay, they're working with timescales so vast they almost break the human mind, trillions, even quadrillions of years. From our perspective, it sounds like forever, but in the cold math of physics, even forever has an end. 2. The Higgs boson clue. In 2012, the discovery of the Higgs boson gave us not just confirmation of a particle, but a clue to our universe's fate. By measuring its mass, about 125 GeV, physicists could model the stability of the Higgs field. And what they found was unsettling. Our universe isn't in a perfectly stable vacuum. It's in a metastable state, like a candle flame that looks steady but could flicker out if disturbed. This metastability suggests that eventually vacuum decay is not just possible, but inevitable. 3. The probabilities. So when could happen? Some models predict the universe could last another 10 to the power of 100 years before decay. That's a number so large, it dwarfs the age of the universe by comparison. Others suggest the odds aren't so distant. Calculations have hinted that decay could occur within the lifetime of stars, still billions of years, but not infinite. And here's the kicker. Because vacuum decay is quantum in nature, it could also, however improbably, happen. Right now, it's like radioactive decay. Uranium atoms can last billions of years, but any single atom could decay this very second. 4. Already happening. Another eerie possibility. Vacuum decay may have already begun somewhere else in the universe. If a bubble of true vacuum formed a billion light years away, it could be racing toward us as we speak. And since nothing outruns light, we'd never see it until it arrived and erased us instantly. This is perhaps the most haunting feature of vacuum decay. There is no timeline, no countdown clock, no way to prepare. It could take longer than the lifespan of galaxies, or it could already be on its way. 5. The paradox of indifference. But here's the paradox. If the apocalypse is instant, random, and unstoppable, does it even matter? Unlike climate change, nuclear war, or asteroid impacts, vacuum decay isn't something we can prevent with technology or policy. It reminds us of an uncomfortable truth. Sometimes survival is not in our hands. So perhaps the question isn't, when will it happen? But rather, how do we live knowing it might? Next, in Chapter 5, The Human Response, we'll explore how scientists, philosophers, and writers have wrestled with the idea of living in a universe that could vanish at any instant. So far, we've explored the physics of vacuum decay, the false vacuum, quantum tunneling, cosmic rays. But now, let's ask the deeper question. How should we live, knowing that reality itself might collapse at any moment? 1. The psychology of fragility. Humans are not built for infinite timescales. We measure life in days, years, generations. When confronted with cosmic threats, gamma-ray bursts, asteroid strikes, vacuum decay, our minds struggle. Psychologists call this existential dread, the anxiety that arises when we realize life, meaning, and even the universe itself are temporary. And yet, instead of paralyzing us, this dread often inspires. The knowledge that everything can end sharpens our focus on what truly matters. Love, art, discovery. 2. Stephen Hawking's warning. One of the greatest physicists of our time, Stephen Hawking, often spoke about vacuum decay. In his book, A Brief History of Time, he noted, "The vacuum is not completely stable. At some time in the future, it could decay into a lower energy state with catastrophic consequences." But Hawking didn't dwell on fear. He used the possibility as a reminder that the universe is fragile and that our search for knowledge is urgent. 3. Culture and myth. Throughout history, every civilization created stories about the end. The Norse Ragnarok, where gods and men fall in fire and ice. The Hindu Pralaya, where the universe dissolves into chaos before being reborn. The Christian Apocalypse, where the world ends in divine judgment. Vacuum decay is the scientific equivalent. Not gods or demons, but the laws of physics, themselves collapsing. And just like those ancient myths, it serves a purpose to remind us of humility in the face of forces beyond control. 4. What scientists say. Modern philosophers of science suggest two responses to cosmic fragility. Practical indifference. Since we can't stop vacuum decay, we should ignore it and focus on solvable problems, climate change, disease, war. Existential reflection. Use the knowledge as perspective, a reminder that meaning isn't guaranteed, so we must create it ourselves. The astrophysicist Katie Mack wrote in her book, The End of Everything, "There's something comforting in knowing that when the end comes, it will be quick, total, and unavoidable." It reminds us that meaning is not given to us by the universe. It's something we choose to make. 5. The professor's takeaway. If I were teaching this in a classroom, I'd tell my students, don't fear the vacuum. Fear wasting your moment in the light. Because whether the universe lasts another 10 to the power of 100 years or collapses tonight, the only timeline that matters is the one you live. So yes, vacuum decay could erase everything. But maybe its greatest lesson is not about death, but about life. Next, Chapter 6, Beyond Science, the Philosophy of Nothingness. Here, we'll explore how vacuum decay ties into ancient ideas of nothingness, from Buddhism to existentialism, and what it teaches us about the meaning of being. We've examined vacuum decay as a physical theory, but to stop here would be incomplete. Because when science tells us the universe itself could vanish, we're forced to confront a much older question. What does it mean to live, knowing it could all be gone tomorrow? 1. The ancient fear of nothing. Humans have always feared the void. The ancient Greeks spoke of chaos, the gaping emptiness before creation. Hindu cosmology described cycles of creation and dissolution, universes born and destroyed in endless rhythm. In Buddhism, the idea of sunyata, or emptiness, isn't destruction but a reminder that everything is impermanent. Vacuum decay, in its own way, is the scientific echo of these ancient myths. Not gods or demons, but the laws of physics themselves collapsing into nothingness. 2. Existentialism and fragility. Modern philosophy also wrestles with this. Think of Jean-Paul Sartre, who said, "Man is condemned to be free." He meant that because nothing guarantees meaning in the universe, we must create it. Vacuum decay embodies this perfectly. There is no guarantee that reality lasts forever, which means that meaning is not something given by the cosmos. It's something we invent, moment by moment. 3. The professor's thought experiment. Let's imagine a classroom thought experiment. I tell my students, suppose a bubble of true vacuum is already on its way, racing toward us at light speed. It will arrive in 10 minutes. What would you do? Some laugh nervously. Some say they'd call loved ones. Some say they'd pray. But all eventually realize the same truth. When faced with the end, the only thing that matters is what you choose to value in the time you have. That, my friends, is the hidden lesson of vacuum decay. 4. Science meets spirituality. Here's the paradox. Science strips away our illusions of permanence. It shows us a fragile, metastable universe. And yet, in doing so, it teaches us something profoundly spiritual. That life is precious precisely because it is temporary. That love, kindness, and knowledge matter precisely because the universe owes us nothing. Carl Sagan said it beautifully. The cosmos is within us. We are made of star stuff. We are a way for the universe to know itself. And if the universe can vanish, then every conscious moment you experience is infinitely rare and infinitely valuable. 5. Closing the circle. So perhaps vacuum decay is not the end at all. Perhaps it is the ultimate teacher. It tells us, don't waste your fragile existence. Don't wait for cosmic guarantees. Create meaning. Live fully. Because if nothingness is inevitable, then everything we do before it arrives is what makes us human. In the end, vacuum decay may not just be about physics. It may be the universe's way of reminding us we are temporary, and that is what makes us beautiful. Next, in Chapter 7, the final reflection and call to action, will close our journey with a challenge to humanity. What will you choose to do with your fragile moment in the cosmos? We began with a question. What if the universe itself could turn against us? We explored the physics, false vacuums, quantum tunneling, bubbles of nothing expanding at light speed. We traced the timelines, trillions of years, or maybe tomorrow. We wrestled with the philosophy, what it means to live when reality itself is temporary. And now, we arrive at the final reflection. 1. The fragile miracle. Think about it. Every breath you take, every conversation you have, every sunrise, every heartbeat, every moment of laughter, all of it exists because the laws of physics, for now, are holding steady. But those laws aren't guaranteed forever. And that's the miracle, that we are here, alive, conscious, in this fleeting window between nothingness past and nothingness to come. 2. The lesson. Vacuum decay teaches us the harshest truth, but also the most liberating one. Nothing is promised, which means everything is precious. If the universe can collapse in a blink, then the only meaning that exists is the meaning you create. As Carl Sagan said, we are a way for the cosmos to know itself. So the real apocalypse is not vacuum decay. The real apocalypse would be to waste the fragile, rare chance we've been given to live. 3. The challenge. So I leave you with this. What will you do with your moment? Will you wait for the universe to end? Or will you create something so meaningful, so lasting, that even if it's erased tomorrow, it mattered today? If this journey moved you, don't stop here. Watch the previous episode in the Apocalypse playlist, where we explore the dark forest hypothesis, why the silence of the cosmos may itself be a warning, and then binge the full Apocalypse playlist, where we uncover the greatest existential mysteries from gray goo to gamma ray bursts. Because the end may be inevitable, but what you choose to do before it arrives is what makes you human.